everyone, welcome to another deep dive. Get ready because today we're going to be tackling a big one, the nature of reality itself.
That's right. We'll be exploring what science has to say about how our universe really works, even if it bends our minds a little along the way.
And the really cool thing is this all came from a question from you, our listener. You sent us some super interesting stuff about reality, and it all starts with something we encounter every day, an apple.
An apple, you say. Sounds simple enough, but as with many things in science, the closer you look, the more you realize just how much complexity is hidden beneath the surface.
Okay, so how does an apple lead us to, questioning the very fabric of reality? Am I about to fall into some physics rabbit hole?
Well, think of it like this. Even ancient humans, without any of our fancy scientific tools, they seem to sense there is more to reality than meets the eye. Think about things like burial rituals, offerings to the dead.
Right, like they believed in a world beyond our senses.
Exactly. And that idea that what we perceive might not be the whole picture, well, it's been around for centuries. Plato, the ancient Greek philosopher, explored this idea with his famous allegory of the cave.
Oh yeah, Plato's cave. That's the one where the prisoners only ever see shadows on the wall, right? And they think that's all there is to reality.
Precisely. They mistake those shadows for the real thing because they have no other frame of reference. And Plato's point was that our senses might be kind of like those shadows, only showing us a limited view of a much bigger, more complex reality.
Okay, I think I see where you're going with this. So, you're saying our perception of reality, what we see, hear, touch, all that, it might not be the full story.
It might not be the full story. For example, did you know that colors, the way we perceive them, well, that can vary from species to species. What looks red to us might look totally different to a bee or a dog.
So my apple, which looks red to me, might look completely different to my dog. It's like we're each experiencing our own, personalized versions of reality.
It really is quite fascinating to consider. But
Yeah.
then things get even wilder when we fast forward a few thousand years and enter the world of who else? Albert Einstein.
Ah, Einstein. The man who really threw a wrench into our understanding of time and space, and
Yeah.
probably blew a few too many minds in the process.
He certainly did. With his theory of special relativity, he challenged our most fundamental assumptions about how the universe works.
Okay, so remind me, what exactly is special relativity? Because I feel like most of us think of it as, that thing that makes time travel possible, which, don't get me wrong, is totally awesome. But there's more to it than that, right?
Oh, absolutely. Special relativity is all about how speed affects time and space. And it all starts with a pretty mind-boggling idea.
Hit me with it.
The speed of light is constant. It never changes, no matter how fast you're moving.
Okay, speed of light, constant. I'm trying to wrap my head around this because it feels like common sense says if I'm running towards something, it'll seem like it's approaching faster.
That's how we experience things in our everyday lives, sure. But with light, it's totally different. Imagine this. You're on a train, and I'm standing on the platform watching you go by.
Okay, got it. I'm on the train, you're on the platform.
Now, imagine a beam of light traveling alongside the train. Both you on the moving train and I, standing still, we would both measure the speed of that light beam as exactly the same.
Wait, even though I'm moving and you're not, that doesn't seem right. How can that even be possible?
That, my friend, is the crux of special relativity. Because the speed of light is this constant, unchanging thing, it means our traditional understanding of time and space has to be adjusted.
So you're saying time and space aren't absolute, they can change?
Exactly. Time and space are relative, meaning they depend on your perspective. An hour for you might not be an hour for someone moving super fast relative to you. It's like that saying, time flies when you're having fun. Well, it turns out time also flies when you're moving at speeds approaching the speed of light.
Okay, my head is officially spinning, but I have to ask, does this mean time travel is actually possible? Because that's where my brain goes every time we start talking about relativity.
Well, it's a question that's captured the imaginations of scientists and science fiction writers alike.
Ah,
And theoretically, yeah, time travel might actually be possible thanks to this strange relative nature of time that Einstein revealed. And we even have some tantalizing hints that it's not just theoretical.
oh, spill the tea. What kind of hints are we talking about?
Well, in 2023, there was a study that looked at quasars, which are these incredibly bright, distant objects, billions of years old.
Okay, I've heard of quasars. They're like the brightest things in the universe, right?
They're outrageously bright, yeah. And because they're so far away, when we observe them, we're essentially looking back in time. And this study, it found evidence that time actually passed differently in the early universe.
Well, wait, so like time was literally moving at a different speed back then. It's like a cosmic time warp or something?
It's kind of like that, yeah.
Okay.
Time wasn't ticking at the same rate throughout the history of the universe. It's more evidence that Einstein was onto something big when he said that time isn't this fixed, absolute thing we always thought it was.
Okay, so time isn't what it seems. It can be warped and stretched depending on things like speed and even the age of the universe itself. This is where I start to feel like I need a whiteboard and like 5 more cups of coffee.
It's a lot to take in,
Yeah.
and it only gets weirder from here. Remember how we started with an apple? Well, buckle up, because that apple, it's about to get a whole lot stranger.
Oh man, you're not going to tell me my apple is actually a hologram, are you? Because my brain might not be able to handle that right now.
A hologram. That's a good guess, but not quite. What if I told you your apple is mostly made up of nothing?
Wait, hold on. Mostly nothing. You're saying my apple, this solid, crunchy thing I can hold in my hand, is mostly empty space. How is that even possible?
It all goes back to the structure of atoms. Remember learning about atoms in school?
Yeah, like those little balls that make up everything around us.
Right. But it turns out atoms aren't solid little balls at all. In fact, they're mostly empty space. And the story of how we figured that out, it's actually pretty wild. It involves a physicist named Ernest Rutherford, some gold foil, and a few very unexpected results.
Okay, so atoms, not solid balls. More like tiny solar systems. That's what I remember from school, with electrons whizzing around a nucleus like planets around a sun. But you're saying that picture isn't quite accurate either.
It's a good starting point, but the quantum world, it likes to throw curveballs. See, those electrons, they don't orbit the nucleus in neat little circles like planets. It's much weirder than that.
Weird or how? Do they like teleport around randomly or something? What's going on in there?
Imagine instead of a tiny point, the electron is more like a cloud spread out around the nucleus.
A cloud. Okay, now I'm really lost. How can an electron be a cloud?
Well, we call it an electron cloud or a wave function. And it basically describes the probability of finding the electron at any given point around the nucleus. It's like we know it's somewhere in that cloud, but we can't pinpoint its exact location until we actually observe it.
Wait, so you're telling me the electron is sort of everywhere and nowhere at the same time until we look at it? It's like it only decides where to be once we're watching.
That's the essence of it, yeah. It's called wave-particle duality. Sometimes those electrons, they act like particles, like tiny marbles. But other times, they act like waves spread out over space.
Okay, hold up. How can something be two completely different things at the same time? That makes my brain hurt.
Think of it like a coin spinning in the air. Before it lands, is it heads or tails?
Well, it's both, right? Or neither, until it actually lands.
Exactly. Until we force it to choose by stopping it, it exists in the state of being both possibilities at once. And that's kind of what those electrons are doing. They're in this blurry state of being both wave and particle until we observe them.
So let me get this straight. We have these electron clouds, which aren't really clouds, but more like probability waves, and they're both waves and particles. My brain is officially fried, but how does all this tie back to my apple?
Because your apple, like everything else in the universe, is made up of atoms. And those atoms are governed by these mind-bending rules of quantum mechanics. Those fuzzy electron clouds, they're what give the apple its shape, its texture, even its color.
Okay, I'm starting to see the connection, but this is where it gets really philosophical, right? If our observation affects how these particles behave, does that mean we're somehow creating reality with our minds?
It's a question that's been debated by physicists and philosophers for decades. Does consciousness influence quantum mechanics? It's a wild thought, isn't it? But even if we don't have all the answers yet, one thing is certain. This quantum fuzziness, it has some pretty big implications.
Like what? Give me another mind-blowing quantum fact to ponder.
Well, how about this? What if I told you that your apple, the very same one you're holding, is somehow connected to distant corners of the universe?
Okay, now you're just messing with me. How can my apple be linked to something light years away? Did someone spike my apple juice with something?
No spiked apple juice needed, I promise.
Yeah.
What I'm talking about is called quantum entanglement. It's one of the most bizarre and fascinating phenomena in the quantum world. Quantum entanglement. That sounds ominous, but also incredibly cool. Okay, listening. Tell me more about this spooky apple connection. What is it and how does it work?
Imagine you have two of those spinning coins we talked about earlier, except these coins, they're linked in a special way.
Linked? How do you mean?
Linked, so that if one lands on heads, the other one instantly, no matter how far apart they are, will land on tails. They're like a matched pair, always mirroring each other's states. That's entanglement.
Whoa, that's seriously weird. It's like they have some kind of secret communication line that transcends space and time.
That's a great way to put it. And it's not just theoretical. Experiments have actually demonstrated entanglement with photons, electrons, even with larger molecules. So you're saying this is actually happening in the real world, that my apple is out there, entangled with particles across the universe. It's like the universe has these invisible threads connecting everything. It's mind-blowing, but also kind of beautiful when you think about it.
It is pretty incredible, isn't it? And it challenges us to rethink everything we thought we knew about how reality works. Because if something as seemingly mundane as my apple can be so deeply connected to the cosmos, well, it makes you wonder, what else is possible? What other mysteries are still out there waiting to be uncovered?
That's a great question, and I think that's a perfect place to shift gears a bit. Because we started this deep dive by questioning what's real, focusing on this apple, but this whole conversation, it's got me thinking about something else entirely. What about us? Are we real? I mean, if the building blocks of reality are so fuzzy and uncertain, where does that leave, our sense of self, our consciousness? I mean, we've gone from this apple, this symbol of like concrete reality, to the idea that the very particles it's made of are governed by probabilities and entanglement. It makes me wonder, where do we fit into all of
That's
this?
a huge question, isn't it?
Yeah.
The question of consciousness, of what makes us,
Yeah.
it's a question that stumped philosophers and scientists for centuries.
Right. It's like we can break down the physical world into smaller and smaller pieces, but consciousness, it still feels like this big, elusive mystery.
And it's a mystery that becomes even more perplexing when you consider what we've learned about the brain. Because on one hand, we know the brain is this incredibly complex organ with billions of neurons firing away.
Yeah. It's like the most powerful computer we know of.
Absolutely. And yet this physical system, it somehow gives rise to our thoughts, our emotions, our sense of self. So is consciousness just an emergent property of all this electrical activity? Or is there something more to it?
Like some kind of, I don't know, quantum consciousness field or something. I know, I'm probably getting a little too out there now.
Hey, it's all fair game in the realm of exploring the nature of reality, right?
Yeah.
But you've hit on something important. The idea that maybe, just maybe, there's a link between consciousness and the quantum world.
Okay, tell me more about that. Is there actually any evidence to support that idea, or is it more of a, like, fun to think about kind of thing?
Well, it's definitely an area of active research and speculation. Some scientists believe that quantum processes like entanglement or superposition might play a role in how our brains process information, or even in the formation of memories.
So you're saying that the same principles that govern these tiny particles, they could also be at work in our own minds? It's a trippy thought.
It is trippy, and there's still a lot we don't know, a lot of research to be done. But it's a reminder that the more we learn about the universe, the more we realize how much we don't know. And that's exciting.
It is exciting. It's like we're standing at the edge of this vast ocean of knowledge and we're just starting to dip our toes in. And who knows what incredible discoveries are waiting for us out there.
Absolutely. And the journey itself, that process of exploration, of questioning and searching for answers, that's where the real magic happens.
That's so true, because I have to say, this whole conversation, it's really shifted my perspective. We started with a simple question about an apple, and it's led us to, like, the deepest questions about the universe and our place in it.
And that's the beauty of asking questions, isn't it? It opens up these incredible pathways of discovery. So to our amazing listener who sent us down this rabbit hole, thank you. You've inspired us to delve into the mind-boggling world of quantum mechanics, to question the nature of reality, and to ponder the mysteries of consciousness.
And to everyone listening, we hope this deep dive has sparked your curiosity, challenged your assumptions, and maybe even left you with a little more wonder about the universe and everything in it. Because at the end of the day, the journey of exploration, that's what it's all about. So keep asking those big questions, keep seeking out new knowledge, and we'll catch you next time on another deep dive.